Hello my dear students and welcome once again to another video for our class in Programming 2. In this video we are going to talk about accessors and mutators. So what are accessors and mutators? In object-oriented programming, encapsulation is one of its most important pillars. One way of enforcing encapsulation is through the use of accessors and mutators. They are used to set and return values of the properties or attributes of an object, which are usually declared private. An accessor is the one that is going to return, or the method that is going to give the value to the one that is using it. The value of the instance variable, which is now declared as private using the private access modifier. There is a certain naming scheme that is generally followed here. The method name is prefixed with the word get, followed by the name of the instance variable with its first letter in capital. For example, the instance variable called string address will have an accessor of get address, which returns a string. These methods should return the same type as the instance variable. The partner for this is the mutator. The mutator is the one that is going to change the value of an instance variable. It is declared, of course, with the private modifier. The mutator and the accessors are all public, but so that they will be accessible by other classes. However, you only use mutators and accessors to instance variables that are declared as private. Unlike accessor, mutators do not have a return type. Instead, it will have a parameter that has the same type as the instance variable it is meant to set. The naming scheme includes prefixing it with the word set, followed by the name of the instance variable. For example, the instance variable string address, we can have a mutator set address with a parameter inside of it, which is a string, and that is how you create or define mutators. But the real thing is, why should we use accessors and mutators? But in fact, if we will just turn our instance variables into public using the public access modifier, other classes can now change those properties very easily without adding more complexity to it. But then again, in object-oriented programming, it is a generally good idea to hide the data of the objects as much as possible. And so we have to make them private, because you don't want that other classes will have direct access to class properties. In that way, you will now have no control as to how these values will be set or how these values are accessed. So that is why we use accessors and mutators. With the use of accessors and mutators, we can change how the data is handled behind the scenes. Without the other classes using it, they don't have to know how it's done. And we can also impose validation on the values that the fields are given. To explain this further, let's take a look at this scenario. Here we have a class user, and we declared two properties for class user: username, which is a string, and ID number, which is an int. With this, if this is declared public or protected, then programs within the same package can access user and can instantiate user, and with that they can access directly the username of each user object. Here, for example, within a program, we create an instance of the class user, which we call user1, and from there, user1 we set the name to this and the ID number to that. Also, in another program, we might have another way, another program accessing our user class and instantiating it like so. But what if we would like to impose rules on the username? For example, we want that a username should only start with a letter. We want that a username cannot have underscores or other special characters. If that's the case, we can never impose such rules on a public property like this one. And that is why we make accessors and mutators. So now here is a modified user class. We still have the string username and int ID number as our properties or instance variables, but this time they are declared private, which means it is only accessible within the class itself. Now within the class, we created two methods, which is set username. This is the mutator, and this why is it set, and the set ID number, which is also the mutator for the ID. With this, when a program uses the class user and create an instance called user1, they will have to call set username to change the value of the username property. Now, since we have it as a method here, we can implement rulings right here in the class user, and may even format whatever is given by the program one as the input for the username. Like for example, within the username method, we can remove the underscore and change the capital G to small letter G, because we are imposing a rule that username is only small letters and does not contain special characters, for example. Or if, for example, the program 1 is going to change the value of the user ID number in this case, we can impose rules that ID numbers should only be positive numbers, so that when a program sets an ID which does not follow that rule, we are not this method is not going to allow it. In that way, we are imposing rules, and even if that rule will be changed, for example, the program 1, which is using the user class, and the program 2, which is using the user class, don't have to worry about those changes, because the changes happen within the method of the user class. So the program 1, the way program 1 and program 2 interacts with user class will be the same, even if we are going to change our logic inside of the user class. So to give it more clearer, the best way to demonstrate this is through coding. So here we are inside of our Visual Studio Code editor, and we start with two classes, the user.java, which is a definition of the user object, and data entry.java, which is the application program that we have that is going to use the user class. So here we have defined user to have two instance variables, the username, which is a string, and ID number, which is an int. And here I've demonstrated that we can instantiate a user using this statement, and we can also change the values of the properties of that user directly, because these are declared without any access modifiers, and since they are not given any access modifiers, its behavior is default, and by default it is accessible. Properties are accessible by classes in the same package, and since the user and the data entry are in the same package, data entry is able to access user1 as well as its username and ID number directly. You can also use these values. For example, we can display the username of that user1 dot username, by simply calling it directly as well. Okay, and this would output uh, the username, which is sassy in this case. I don't know if this works right here. Yeah, there you go, sassy. However, uh, we want to implement pure encapsulation so that we should not allow data entry to access username and ID number of user directly. So we can implement accessors and mutators. And the first thing we need to do is convert or provide an access modifier for username and ID number with private. So we add private there and we add private there. So now these statements are invalid because data entry do not have access to username and ID number directly anymore. All right. And next thing is we are going to add accessors and mutators. Let's start with accessors. And accessor is public, should be public, and will return the value the same type as the property. So if this is the accessor for username, it should return a string, and it should start with a get and then username. And this will simply return the username. Same with ID number. Since ID number is an int, the return type should be int, and we say get ID number. And it should just return the ID number itself. Okay? So now we can fix this by, instead of directly accessing the username, we simply call get username instead. So now it's valid. However, our changes in data is still invalid because we don't have mutators. So let's add mutators here. Public. This should be void, and then set, and then username. But here inside of the parentheses, we need to provide the property on the parameters, and this should be string. All right. Now we simply say username is equal to the UN. So what happened here? Whatever string is being passed by this method when you call this method will be assigned to username. So technically we're saving, or we're changing the value of username through this mutator. In the same way, we'll also have public void set ID number, and here we pass in a string that is an int, and let's just put ID there, and we say ID number is equal to ID. So now we have completed our accessors and mutators for our two properties. Now we can change this. The way we now change our username is through the use of set username, and we put inside of here an argument, which is a string, and this string will be the one that is passed into this parameter, which in turn be assigned to the username. Same with ID number here. We say set ID number, like so. So now it's okay, and this argument int is being passed into the ID parameter, which is then being assigned to ID number right there. Now data entry is able to change values of the properties of user, but not directly. So this program still works in the same way. And there you go, you have SASE, and it runs. Now again, the question of why should we do this is, for example, we want to implement rules into how usernames should be written. For example, we want that username should only be in small letters and should not contain any It should not contain any special characters, for example. Then that rule can be applied here. So for example, if we are going to assign sassy underscore and then question like that, we can implement some code here that is going to remove these characters that are not allowed, and then set it there. Okay, instead of directly changing it there directly, we can have a code logic that checks for texts that are not allowed. For example, uh, we write that logic inside of here before, and finally we assign username with the new string which is being cleaned up by our logic. I hope you understand that kind of thing. But for now, let's just skip that one. Okay, for example, if we want that our user's ID number should not be a negative, okay, we can implement that rule right here. We can easily implement that rule right here, so that we can say instead of directly saving the ID into the ID number, we can still make that into a positive number by wrapping it up inside of an absolute value function. So like for example, you say ID number is equal to math.abs ID, so that even if the user puts negative here, it will still be converted into positive number, like that. So if we are going to display user1 that get ID number, okay, remember we are trying to set it to a negative value, but since we have some logic inside of our set ID number that changes everything to positive, then this should be positive right here. So let's try and run this program, and there you go, we have sassy and it's positive. Okay, so that is one big reason for using accessors and mutators. So that's it for this video. I hope you have learned something from this, and see you again in the next one.